Hello people from the internet, Mr. Crowley here. So today we are going to talk about the indefinite integration. To start, we have to start with the definition of integration. We all know that the differentiation is we find the derivatives from the original, but integration is essentially the other way, is that we find the original function from the derivatives. So integration has two major types. The first one is indefinite integration, which is what we are going to talk about today, and this one has our constant c in the end, because when you are finding the derivatives, and the derivative of the constant is always 0, so therefore we always have a c. And the other type is definite integral, which has a upper limit and a lower limit, but we are not up to that part yet, so we will talk about this later, maybe in the next video. And today we are going to be focusing on the indefinite integral. To start, here is what a definite integral look like. Now paying attention to this, the first part, this part is basically the sign of integration, but notice we don't have the top and the upper limit and lower limit. And this one is the function. This one indicates that the x is the independent variable, but in this case we don't have any usages for this. This becomes useful when we are talking about volumes and use substitutions. So we will talk about this later in this video. And this one is the f of x, which is our original function, and in the end we have the constant c, which is always there. Be careful, you cannot miss this part when you are doing the indefinite integration. And to start, the most important part is in the indefinite integration is the power rule. Now here's the power rule. Now this is basically the reversed way of the power rule in the differentiation. And in this case, we just use n plus 1, x raised to the n plus 1's power and divide by n plus 1. This is very important. Actually, in my opinion, this is the most important part in the indefinite integration. So now we're going to take a look at an example. So if we want to find the indefinite integral of x squared dx, this one just equals to x raised to the 2's power 2 plus 1 divided by 2 plus 1 equals to x raised to the 3rd over 3 and plus c. Be careful, do not forget about that. Alright. And now we know that it's the differentiation, since the differentiation and the integration are reversed, they are just reversed, therefore they have a lot of traits in common. Like for example, like if you have a constant before your unknowns, you keep the constant when you are doing the integration. And if you have like plus or minus signs between each part of the function, then you can differentiate. Then you can integrate each individual parts and plus them together. All right. So we are going to take a look at another example. For this one, we have the integral of x raised to the third plus x squared dx. And to do this, we utilize the power rule. Therefore, we have x raised to the third 3 plus 1, its power divided by 3 plus 1 plus x raised to the 2 plus 1 power divided by 2 plus 1 plus c equals x raised to the 4th divided by 4 plus x raised to the 3rd divided by 3 plus c. Now this is the answer. Notice that we keep the plus sign since they are very similar. So therefore we can keep the plus sign or minus sign. It's basically the same. Alright, so now here's another thing I want to talk about. It's U substitution. When you say, for example, like x plus 1 raised to this function, the integral of x plus 1 raised to the second power dx. In this case, when you say like a polynomial or a trigonometric function is being squared or it has a power, you will need the U substitution to do so. The U substitution is basically you let U equals to x plus 1, which is the part inside the power, and then you differentiate both sides. Notice we are going to differentiate, not integrate. So we get du over dx equals to 1. Therefore, later on we can say du equals to dx. Since we multiply dx on the both sides of the equation, then we can substitute this back to the original. Therefore, we get u square. Notice we just replace the x plus 1 with u, and here we have a square. Then we du. Here's what we get because du equals to dx. Then the answer is u raised to the 3rd divided by 3 plus c. And then we substitute x plus 1 back. Then we get x plus 1 square, third divided by 3 plus c. So this is like the most basic parts of the indefinite integration. So in my next video, we're going to talk about the trigonometric functions and some more complicated form of indefinite integration. Alright. I hope you learned something today. I hope you enjoyed my video. If you find this video helpful, please subscribe to my channel and click the like button down below. I will see you next time. This is Mr. Pro Lee.